Welcome to the video. In this video, let's try to find the natural response of the system described by the difference equation y of n minus 1 by 4 y of n minus 1 minus 1 by 8 times y of n minus 2. This is equal to x of n plus x of n minus 1. The initial conditions are given as y of minus 1 is equal to 0 and y of minus 2 is equal to 1. So let's get started. We know that the natural response of the system is the response when we do not have any inputs. So that means there is no x of n. So first and the foremost thing is we should reset these values of x of n. So I'm going to rewrite the equation as y of n minus 1 by 4 y of n minus 1 minus 1 by 8 times y of n minus 2. This must be equal to 0. This is because x of n should be equal to 0 for finding natural response. Okay, now let's continue. What we do is we take the unilateral z transform of this entire difference equation. So taking unilateral z transform, I'm going to write that now. Taking the unilateral z transform, we have the following equation. So y of n gets as y of z minus 1 by 4. Now let's get started with y of n minus 1 term. Y of n minus 1 term has its unilateral z transform as y of minus 1 plus z raised to minus 1 y of z. Now this is what we have for the second term. Let's do it for the third term as well. Minus 1 by 8 is constant into the unilateral z transform of y of n minus 2 is y of minus 2 plus y of minus 1 into z to the power minus 1 plus z raised to minus 2 into y of z. Now this is what we have for this term. Now this should be equal to 0. Now what we do is we collect the similar terms together. So I have y of z term over here. There is one more y of z term here. And then there is one more y of z term here. So let me try to group together similar terms. So y of z, if I take common, I'm going to have its coefficient as 1 here. And the coefficient of y of z term here is minus 1 by 4 z to the power minus 1. Minus 1 by 4 is coming from this particular side. And then the coefficient of y of z term over here is z raised to minus 2, which is getting multiplied by minus 1 by 8. So we have minus 1 by 8 z to the power minus 2. So this is what we have for y of z. Now the remaining terms, let's go with the y of minus 1. So I'm going to have this as minus 1 by 4 y of minus 1. So this term is taken care of. Now let me go with y of minus 2 term. So I'm going to write it as it is, no changes being made. Minus 1 by 8 y of minus 2. So this is also taken care of. And this term, let's have this as minus 1 by 8 y of minus 1 into z raised to minus 1. Now this should be equal to 0. So all the terms have been taken care of. Now let's try to substitute for the initial conditions and then see what happens. So the first term is y of z. This is intact. So we have still 1 minus 1 by 4 z to the power minus 1 minus 1 by 8 times z to the power minus 2. Then minus 1 by 4 into y of minus 1. Y of minus 1 is given as 0 minus 1 by 8 y of minus 2. Y of minus 2 is given as 1. So I'm going to write this as 1 over here. Minus 1 by 8 into y of minus 1. Once again, y of 1 minus 1 is written as 0. So this term is going to vanish. So this must be equal to 0. So if you look at it, the term will be y of z into 1 minus 1 by 4 z raised to minus 1 minus 1 by 8 z raised to minus 2. Now anyways this term is 0, and then we have minus 1 by 8, and this term is also 0, so this should be equal to 0. So if I try to rearrange this, this is going to get me y of z is equal to, if I take this constant to the other side, it's going to be 1 by 8 divided by this entire expression. That means we have 1 minus 1 by 4 z to the power minus 1 minus 1 by 8 z to the power minus 2. So now I must be able to find an expression for y of n, because that would constitute for the natural response over here. So what I do is I will try to solve for y of z using partial fraction expansion method. So just for our reference, once again I'm going to write the value of y of z is equal to, from the previous slide you can see here that it is 1 by 8, 1 divided by 8 divided by the entire expression which is given in the denominator. So we have 1 minus 1 by 4 z to the power minus 1 minus, if you go back, we'll have, yes, minus 1 by 8 times z raised to minus 2. So this can be solved using a partial fraction expansion method. So I'm going to first of all factorize the denominator. So numerator is as it is, and then in the denominator we can find here that the factors are 1 minus 1 by 2 z to the power minus 1 into 1 plus 1 by 4 z to the power minus 1. So this can be very easily written as a by 1 minus 1 by 2 z to the power minus 1 plus b by 1 plus 1 by 4 z to the power minus 1. Therefore, if I have to calculate the value of the first residue a, it will be y of z into the denominator, which is 1 minus 1 by 2 z to the power minus 1. This entire expression being evaluated at z equal to half. So this can be written as, so if you look at this expression y of z, it is 1 by 8 divided by this denominator. So if you try to multiply it by 1 minus half z inverse, then this is going to cancel out over here. So I will have 1 by 8 divided by, this term gets cancelled out, so we have 1 plus 1 by 4 z to the power minus 1. So this being evaluated at z equal to half. So this is 1 by 8 divided by 1 plus 1 by 4 into 2, because z inverse is going to be 2 in case z is equal to half. Now this particular value gets evaluated as 1 divided by 12. So this is the value of a. Similarly, let me find the value of b. b is given by y of z into its denominator, which is 1 plus 1 by 4 z to the power minus 1. Now, this must be evaluated at z is equal to minus 1 by 4. This is very, very crucial. So I can always look at this value as 1 minus of minus 1 by 4 z inverse. So this actually leaves me with the equation as, if I have 1 plus 1 by 4 here, so this gets cancelled out with this particular term. So I will be having in the denominator 1 minus half z raised to minus 1. This being evaluated at z is equal to minus 1 by 4. That's very important. So this is 1 by 8 divided by 1 minus 1 by 2. Z is minus 1 by 4. So z inverse is going to be minus 4. So this, when evaluated, uh, gets me the answer as 1 divided by 24. So this is the value of b. Okay, so I can rewrite y of z in terms of a and b. How? Let's say this. So I would write, therefore, y of z is equal to, first of all, the value of a, that is calculated over here, which is 1 divided by 12 divided by its denominator. Denominator is going to be 1 minus half z inverse. So I'm going to write that down. 1 minus half z inverse plus b. B was evaluated as 1 by 24. So I'm going to write that now. 1 by 24 divided by the denominator, which is 1 plus, you can see here that it is 1 plus 1 by 4 z inverse. So I'm going to write that now into z to the power minus 1. So this is what we get. So now the last step is we should take its inverse z transform. So take the inverse z transform. We have the natural response yn of n, this being equal to, we know that 1 by 12 is a constant, so that's simply kept as it is. Now we know that 1 divided by 1 minus alpha z inverse forms a z transform pair with alpha raised to n u of n. We are talking about the one-sided z transform now. So 1 by 12 into 1 by 2 raised to n u of n. So this is the inverse z transform of the first term plus the inverse z transform of the second term is 1 divided by 24 because that's a constant value now. Now I can always write 1 plus 1 by 4 z inverse as 1 minus of minus 1 by 4 z inverse. So I know that its inverse z transform is minus 1 by 4 to the power n times u of n. So this is how we find the natural response of the given difference equation. Thank you for watching the video.